time, would you? Okay, this is just the back of the worksheet we just did. We're going to be turning this in, so if you need paper, I have paper in the basket. Okay, we've already done this once. Who can tell me the parent function of absolute? Don't do it on the back of your worksheet. We're turning this in. So you need a new lined piece of paper for your notes. If you don't have paper, there's paper in the basket. A new piece of paper. So you need paper? Oops. What is the absolute value parent function? The most basic way we can write the absolute value function. With lines. Absolute value x. Y equals absolute value x. And we just discussed that a minute ago. Okay? So if we were to graph this, we would need to know the vertex. Because when we graph, we need to be graphing around the center, which the center is the vertex. Okay? Remember the saying, opposite, same. What number is in here with the x being added or subtracted to the x? What number is inside the absolute value after the x being added or subtracted to the x? Is there a number next to the x? No, so what number is that? 0. And what number is being added or subtracted outside? 0. So the vertex is 0, 0. So put that in the middle. 0, 0. And we need a couple numbers smaller. Laura, can you give me two numbers just smaller than 0? -1 and then one more. -2. Those will work. Thank you. Okay, and two numbers just bigger than 0. Bella? 1 and 2. Okay. Does everyone understand how we choose these? We need the vertex in the middle, and we need a couple smaller and a couple bigger. Okay, then we do work to get the other y values. Work means we take the -2 and we plug it in this case, into the absolute value. Absolute value, -2. Okay, Alexis, what's the absolute value of -2? It means how far away from 0 is -2. Good, because distance has to always be positive. Then we do absolute value of -1. Cameron, what's that? Okay, positive. Okay, fingers in the air. What y value should I put with x equals 1? Fingers in the air, what should it be? Good, and what about here at x equals 2? Why do we know these automatically without doing work? Because of symmetry. Good. Okay, so let's draw the graph. Notice none of the numbers are smaller than -2 or bigger than +2. Before you start, put your phone away, please. Before you start doing the graph, you should look at your numbers so you know how to set it up. -2, +2, they should be evenly spaced, as good as you can get by doing it by hand. You need arrows, you need to put X, and you need to put a Y. And then plot the 5 points. What shape should it take? It should be a V. So once you got 5 points on your graph, Once you get those 5 points, make sure you connect them with a sharp corner at the vertex, like a V. And the graph continues forever, so we need arrows. Okay, on our introduction, we talked about a graph like this. How many pieces does this have? How many pieces does this graph have? No, there are 2, right? Because here we have a negative slope, and then it changes to a different piece, and we have what type of slope here? Positive slope. So we have 2 pieces. We're now going to write what our lesson's on today is called piecewise functions. We're going to write it in the pieces. Piecewise function. Piecewise, I before E, piecewise function. Okay, I'm going to do the unsimplified version first. So piecewise is still an equation. We still have y equals, but we have, in this case, 2 pieces. So I'm going to do a squiggly brace. There can be more than 2 pieces as well. And I'm going to find the equation for this first piece. This first piece has a negative slope, and it is linear. Didn't we just talk about how we write linear functions? Y equals mx plus b. Starting with the y-intercept. What's this guy's y-intercept? 0. Okay, so b would be 0. Plus, we need to find the slope. What's the slope? Rise over run. Rise over run. What's the slope? 1 is going up, though. I'm going down. -1, and how many do I run? 1. So my slope is -1 over 1 plus 0. That's the unsimplified version. It's going to simplify. Okay? Now this happens on a specific domain. This arrow here tells us it goes to the left forever. What number on the x-axis is way out on the left? And then we have a negative slope until what x value? 0. So this is, we put a comma, it goes from -infinity is less than x, which is less than or equal to 0. We don't put equal on the infinities because we never actually hit the infinities. But we can hit 0, so I'll put an equal to on the 0. -infinity is less than x, which is less than or equal to 0. That's the domain for that piece. But then it changes, and all of a sudden it starts going up. So again, we need y equals mx plus b. What's b? What's the y-intercept of that piece? It crosses, I heard one person, I think it was Noah over here, say it. Where does this graph cross the y-axis? Okay, guys, your eyes actually need to be over here instead of playing with stuff on your wrists and pencils. Put your eyes over here. Where does this graph cross the y-axis? 0, same spot. Then we need to find the slope. Here's my steps. Yeah, this time we're going, whoops, sorry, my sleeve did that. Up 1, over 1. Up 1, over 1. So I call this the unsimplified because I'm pretty sure those fractions both come out really nicely. The piecewise function then would be, in the 2 pieces, -1 divided by 1 is just, -1. So -1x. Do I need to put plus 0? Is there any reason to write plus 0? No. So we'll just put that on the domain -infinity, which is less than x, which is less than or equal to 0. It looks like we never wrote our domain for the second piece. Where does this second piece start? Which x? Because domain is x. Colby, sit up, please. What's this x? 0, and then it continues to the right forever because of this arrow until what x is forever to the right. Pause infinity. Now here's the problem. We cannot put equal to 0 on this one. Only one of them can be equal to 0. So if I put equal to 0 on this one, my second piece can only be less than, no equal to. X, which is less than infinity. It really doesn't matter which one gets the equal sign on if the top one gets the equal sign on 0 or if the bottom one gets the equal sign, but only one of them gets it. They both can't have equal. And you can also not, unless there's a hole there, one of them needs the equal to sign. So if I give it to the top guy, the bottom one can't have the equal to on the 0. Now our second piece said 1 over 1x. Isn't that just the same thing as x? Plus 0, there's no reason to write plus 0. So this is the piecewise function. It shows the equations for the two pieces. We have a linear that's decreasing and a linear that's increasing. Okay? Okay, on our next example, I'm going to give you the piecewise that will look something like that, and we're going to graph it. Example 2. Graph the piecewise function. F of x equals negative x plus 4 for when x is greater than or equal to 1, and x squared minus 1 for when x is less than 1. Okay, on your homework tonight, I've given you a bunch of graphs, and I've given you a bunch of piecewise functions already written out. You just have to cut them out and glue them and stick them on the graph that matches. Okay? Okay, we have a couple different functions here. Justin, what type of function's on top? Negative x plus 4. What type of function is that? X to the first power? Is this quadratic? Linear, right? Because it's x to the first power. What about this one on bottom, Miriam? X squared minus 1. That's quadratic. So we have two pieces. We have a linear piece, and then we'll have a quadratic piece. And we need to get points for both of them so that we can graph them. Okay, now the linear piece says it's only linear for x's greater than or equal to 1. AJ, can you give me some x's that are greater than or equal to 1?
Greater than 1?
Or equal. Is 1 considered greater than or equal to 1? Yeah, and then 2, he said. Can you give me a couple more? And maybe 5. Okay, when we're doing our table of values, we have to use the 1. If that's what it says is the changing point between the two pieces, you have to use that on your table, so make sure you use it. Okay, and then we do some work to get those points. Using negative x plus 4, you plug in negative 1 plus 4. Negative 1 plus 4. Tyson, what's negative 1 plus 4? 3. Good, because it's the same thing as 4 minus 1. Okay, Grail? To your right, please. Then we do it again. Negative 2 plus 4. Okay, Christian, what would that be? Negative 2 plus 4. Yeah. It's the same thing as 4 minus 2. There you go. I know, it's been a long break. Okay? Next one, negative 3 plus 4. Whenever I plug in, I like to put parentheses oftentimes. What do you have there? Yeah. 1. Do you guys see a pattern? 3, 2, 1. What should the next one be? 0, and then the next one should be? Not 1. Negative 1, because it's linear. Linear has a consistent pattern. The jumps in between should be exactly the same. So we notice after we've done 3, we can see the pattern. Okay? Now quadratic. We need to get an XY table. Go in for quadratics and then we'll be ready to graph. Okay, you might want to use a different color. If you want, you can use your colored pencils. But we have to use the 1. See how everything happens around the 1? Even though we used 1 on this table, they both have to have the 1, because something changes at the 1. And then we need to list all x's less than 1. Okay, what are some x's less than 1, Arya?
0.
Okay, give me a handful.
-1, -2, -3.
That's probably good. 5 should be plenty. Okay, then you do some work, plug them in, and then we'll be ready to graph a pretty picture. This one comes from the bottom function, so it changes. It's no longer linear. X squared minus 1. So make sure, uh-oh, it's doing something weird. I have the scrolly bar of death. Oh. Apparently I did like a copy and paste or something. X squared minus 1. Make sure you put parentheses. X squared minus 1. With parentheses and exponents, you have to do those first. Okay, Dago, what is 1 squared? And then we can subtract. What is 1 minus 1? 0. Good. Okay, then we do it again. 0 squared minus 1. Okay, Miklo, what's 0 squared? Because we have to square first.
0.
Minus 1, and we get negative 1. Okay. Isaiah Cooper. Negative 1 squared minus 1. Isaiah Cooper. Negative 1 squared minus 1. You have to square first. What's negative 1 squared?
1.
And if we subtract 1, we get what? 0. Look what happened. We had a repeat because the one between the repeats is called something special. This is a quadratic, so that would have to be the vertex. That's your vertex. Okay, we have 2 more to do. Negative 2 squared minus 1. Okay, negative 2 squared is what? 4. Minus 1, we get 3. And the last one, negative 3 squared minus 1 is 9 minus 1, which gives us 8. Okay? Before you start drawing the graph, you need to look at those numbers. What's the smallest negative number on both of the XY tables? Negative, nope, there's a negative 3, I see. What's the largest positive number on both of the tables? 8. So I'm going to take my axes from negative 3 to 8. Both of them. Okay, if you need help drawing straight lines, use the side of your calculator. 1, 2, 3. Make sure they're evenly spaced. 1, 2, 3, 4, 5, 6, 7, 8. Make sure you label numbers on them. X's and arrows. 1, 2, 3. Oops, that one's not very good. After you have graph set up, stop before you start plotting points, please. You have your graph set up? Okay, we have something special that happens on piecewise functions because we have the inequality signs here. The linear function up top says x is greater than or equal to 1. Remember back in 7th grade when you first started graphing inequalities, there were differences between open circles and closed circles? Which one goes with the equal to? Equal to. Is that going to be open or closed? Okay, why don't you show me what you think it is? This is open. This is closed. Do you think it will be open circle or closed circle? Put it up high in the air, please, so I can see it. Open circle or closed when we say equal to? Diego, Friel, put it up in the air. You have 50-50 shot. Gavin, open or closed? What do you think? Nico? Equal to. Is that open or is it closed? Amara, what do you have there? Which one is that? For equal to. I can't tell which one you're doing. Are you doing open? Can anyone prove if theirs is open or closed, why it's that way? Stetson, which one are you doing? Why are you choosing closed? Because it looks cool. Okay, Christian?
All of those plus that number.
Yeah, this one is including the point. So for including it, we have an extra line. We're going to do an extra fill. So would you draw, please, right by this one? A closed circle, extra line means extra fill. And also by that point, 1, 3, I'm going to put a closed circle so I remember when I graph, it better be a closed circle. Colby, stop, please. Versus this one is x is less than 1. There is no equal to. So should that be open or closed? It should be open because there's no line, which means no fill. So on my 1, 0, I'm going to put an open circle because I have two different ones. One of them will be filled in. The other one will be open. Okay, so now we're ready to graph this linear. I'm going to put an open circle, or a filled-in circle at 1, 3. Nice and big. Filled-in circle at 1, 3. And then plot the other points. Miklo, come on, plot them, please. 2, 2. 3. What am I doing? That is not 2, 2. Okay, this way. 2, 2, 3, 1, 4, 0, 5, 1. Is that looking linear as we predicted it to be? Yeah. So, but this point on the far left is an endpoint. So from that endpoint extends a ray. A ray has a starting point and then an arrow that goes on forever. Okay, the other one is quadratic. So when we plot the points, it should not look straight. It should be curved like a quadratic parabola. So we need to do a big open circle at 1, 0. So 1, 0, we have an open circle. And then we have some other points. 0, -1. -1, 0. You should start seeing it curve like a parabola. -2, 3, -3, 8. It is open, right here. And then from that endpoint on the right, we curve it around with an arrow, so it goes on forever. And there are two pieces of this piecewise graph. The important part of the graph revolves around the 1. So there are 2 points at the 1. One of which is open, this one's open, and this one's closed. What would happen if both were closed? What would be wrong with both being closed? Do you know why? Because we call this a function. In order to be in a functional relationship, how many people can you be dating at one time? One. You can't be dating two people. Even though y equals 0 and y equals 3 are both really pretty, you can't date both of them. Only one, or you're not in a functional relationship. That's why there can be a filled-in circle on one and an open circle. Otherwise, the vertical line test fails. Okay, one more. And this time I'm going to give you the graph and we're going to write the piecewise function. Example, whoops, what happened? Example 3, the last example. Given the graph, write the piecewise function. Okay, so I'm going to tell you where these points are so that you can carefully graph what I have. Is that straight? Yeah. Okay, on your x-axis, go out to -4 and +4. Jeff? On the y-axis, go up to 8. So you're going to have to do it small if you drew it like mine. 1, 2, 3, 4. Maybe not that small. 5, 6, 7, 8. Okay, the points that are given are -4, 7. -2, 5. -4, 7 is a point. -2, 5 is a point. 1, 5 is a point. And 2, 7. And they're all connected. So straight, 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 with arrows continuing on. I think it's much easier to graph when given piecewise. It's a little harder to start with the graph and write the piecewise, for some people at least. So on your assignment, you don't have to do that. You just have to cut out the piecewise and glue it onto the graph that matches. Okay? What type of function is this? Well, actually, let's put fingers up in the air. How many pieces are there? How many pieces do you see this time? Are there 2 pieces? 5 pieces? How many pieces? There are 3, right? First we have this piece. What type of piece do we have at the beginning? Is it quadratic? It's what? It's negative and it's linear. Here we have another linear. What's the slope of this linear piece? 0, it's flat. And then it goes positive. So they're all linear. Okay, so we can use y equals mx plus b to help us write our piecewise. And piecewise has y equals, or you can say f of x equals. Maybe this time I'll change it up and put f of x. When you do your squiggly brace, make sure you have enough room to write 3 pieces. They're all linear, so first you need to find the y-intercept, which this first piece doesn't really continue. So let's look at the slope so we can continue the slope on so we can find the y-intercept. How far down do we have to go to be even with that point? Negative 2, yeah, because we're going down. And how many do we run? Because we're at negative 4 and then we run to negative 2. How many do we run to the right? 2. Alexis? Okay, so our slope is negative 2 over 2. Okay, so I'll start with that and then we can simplify it in a minute. If we continue that, I'm just going to do dashed. I go down 2 more and over 2 more. What's my y-intercept? What? Y is right there. 3 plus 3. And I did that dotted because I was just adding to the graph. And this happens for certain x's. It goes to the left forever. Which x is to the left forever? Negative infinity, which is less than x, which is less than or equal to. All of a sudden, we change pieces at which x value? No, what's the x value? Negative 2. Remember, we don't put equal signs on the infinities because we'll never actually make it to infinity. But we can put infinity on, or the equal sign on negative 2. Because there's a point there. Next, we have a new piece. From here to here. What's its y-intercept? 5. Okay, and what's the slope? Brianna, what's the slope of that piece? 0. It's flat. So 0x plus 5. Okay, now this one starts at negative 2 and then ends at what x value? 1. And again, x is our domain. But we've already used the equal to. So can I put an equal to on this one, negative 2? No, so it just has to be less than. X, which is less than or equal to 1. I can put the equal on the 1 because I haven't done that yet. Any questions so far? Okay, there's one last piece. This piece increasing with a positive slope. But again, we don't know the y-intercept. So let's look at the slope. What's the slope? How many do we go up? We go up 2 and we go over 1. So our slope is 2 over 1x. If we continue that backwards, going down to left 1, our y-intercept would be no, those are the x's though. 1 and 2 are the x's, so that's your run. The up is the y's, 5 to 7. Okay, so our y-intercept again is 3. So it's the same as that, guys. Plus 3. But this happens on a specific domain from 1 until what x value? Equal, turn around please and write these down. 1 until infinity. But we've already put an equal sign on 1, so can this one have an equal sign? No. And also infinity does not have an equal sign. Now that would be okay, I guess, to leave it like that, but I'm pretty sure those fractions simplify. Nate, you're not done. You're not done. Negative 2 over 2 is negative 1x plus 3. And then my domains stay the same that I wrote above. Do we need to write 0x? No, because timesing by 0 does nothing. It becomes 0, so it's just a constant 5. When you say a constant, that's a flat line. And 2 over 1 is just 2x plus 3. 1 is less than x, which is, less than infinity. And that would be the really nice way to write it. So, once again, your homework is to take these graphs, the second page. Oh, I'm doing this. Put your pencils in the box, please. The second page has the piecewise. You just need to cut them out and glue them on the next to the matching graph. Does that make sense? Cut them out and glue them next to the matching graph. Please put the pencils in the box and you can just leave them on the end in the aisle. Yeah, you can put it. Oh, I don't have the folders out. We'll turn them in next time. Yeah, you can use tape. That's fine. Make sure you don't leave without having this packet. Were there 4 of you back here?
They were.
Please return your calculators.